Hello, welcome to the RF Insights. In this video, I'm going to briefly review the digital elevation models for RF simulations. There are multiple different sources and types of digital elevation models that RF simulation software use in order to model the variation in ground height in an area that you want to simulate the RF propagation, microwave links, etc. Digital elevation models, or DEMs, are gridded datasets that represent the Earth's surface elevation and are widely used in RF simulations, and also for wireless planning and terrain analysis to account for obstacles, diffraction, and line-of-sight conditions. They're typically collected through remote sensing techniques such as satellite radar, light detection and ranging methods, photogrammetry from aerial imagery, or ground surveys. Common DEM types include DTM, or digital terrain model, which represents bare earth elevations without vegetations or buildings, as well as the other models called DSM, or digital surface models, which include terrain data plus the clutter, for example buildings and vegetations as well. So these digital elevation data could have different resolutions from sub-meter accuracies for very high accuracy data sets to 30 meter and 90 meters are common as well. So here you can see a list of commonly used digital elevation data that are used by common RF simulation tools. I personally use the first one, ASTER GDEM V3, for my simulations. This has 3 meter accuracy, which is sufficient for the purposes of my study. So ASTER GDEM V3 is derived from stereo optical imagery by NASA and Japan's METI with a 30 meter resolution globally. So it covers the whole Earth. Version 3 improves vertical accuracy and reduces artifacts compared to earlier releases. The next data type is generic GeoTIFF, a common raster format that stores elevation data in a standardized georeferenced form and used widely because it's compatible with most GIS and RF planning tools. Next one is Infoterra LiDAR, which is a high resolution elevation data collected via airborne LiDAR surveys and provides very detailed digital terrain model or digital surface models in a sub-meter accuracy suitable for urban or critical RF modeling. Next one is NED GeoTIFF and also Ofcom DEM, which is released by UK regulator Ofcom, and also SRTM 3 HGT. The TSLSWBD merged SRTM version 3 is a process dataset that merges SRTM3 with the TerraStar X land sea water body database to collect coastline and water surfaces, ensures improved accuracy of terrain near shorelines for modeling the systems that are operating very close to the body of water. So here you can see a summary of the tape, resolution, coverage, format, and RF simulation use case for all of the data sets that we presented in the previous slide. Feel free to pause and read this table to see which one suits your work. So if you want to have a closer look at the TIFF, GeoTIFF format as an example, a TIFF by itself is just a grid. Each cell is 1 pixel, but with no knowledge of where on Earth it is. The GeoTIFF header or metadata includes some reference information or special tags that tie the grid to the coordinate system. The origin, or on the top left corner of the tile, is latitude and longitude or projected coordinates. Then we have the pixel size, which defines the resolution of the TIFF file, and then we have projection info. Here in this case it's WGS84. It could be WGS84 or NED 83, etc. Now each pixel index, which is a combination of row and column, can be converted to a geographical coordinate using the formula that we have. So when software loads the GeoTIFF data, it doesn't just see a gray image, but it knows for example, pixel number 23, row 2, column 3 is 103 meters high, and at what coordinate it's located. Okay, so now you can trace the RF path, diffraction edges, clatter masks correctly that are tied to the geography. There are if you need a digital elevation model, first you have to know what type of model you're going to use based on your needs, and then you can download it, hopefully free, on the internet. As I said, I normally use ASTER version 3 data, which is available for download from NASA website. I will put the link to this website, to this NASA website in the description, so you can go see. So if you go to this link, this is the NASA Earth data. Then you choose Access Database, and then you choose the Earth Data Search here, and you press download. You're gonna go in this page. Now here you have to zoom in the area that you want the data for. For example, I go to area near Kingston in Ontario, and you just draw, like, you can draw different kind of shapes. I draw a rectangle here for simplicity. I want the data for this area that I chose. So then you have to come here and choose ASTER version 3. It's gonna look for the information, and it's gonna tell you that you have to download the information for this tile. Then you choose download all, and the data is going to be downloaded on your computer. Okay, then after you saved it on your computer, you can load it on the software that you want to use. I just want to quickly show you what it looks like. So ASTER version 3 data, it basically, if you open it, it's an image file. It looks like this. There's no useful information to see here, but if you look at the name of it, there is it shows N42 north or W08 west. So it shows the coordinate, the top left coordinate of the tile that you have downloaded is the coordinates of this point pretty much here. And so you have to download the tiles that covers your area in order to be able to do the simulations. Okay, then I want to show you how we actually load this data in the software. So just give me a few minutes so I can open the simulation file, and I want to load it for you. As I said, different software use different kind of elevation data, and depending on your application, you may find it easily, or it might be difficult sometimes to find the source. I know that the Canadian government also has a source of digital elevation data for parts of Canada. It's called the CDEM, or yeah, but I used to use that, but I find this ASTER version 3 really useful. So here I have this microwave link here. Okay, I want to basically load my terrain data. There is no terrain data at the moment, so I come here and I choose the area that I want, choose the type of the terrain data, ASTER version 3, and the software is going to load the information here for me. Now to verify, I will create a watch window here. I want to see what is the height of the terrain. For example, at the location of station 1, go here and I choose the terrain height, and I can see it as 269 meters. Station 2 is at 287 meters. So I have successfully loaded the terrain data for my link here, and I can also see the path profile for this link. So if I go here, I choose the path from station 1 to station 2, then I can see the profile. You know, it shows me what elevation is the in the location of the path. For example, here is the highest point of the path. It's at 332 meters, right? And here you can see that the software also takes into account the curvature of the earth, which makes things worse, right? Yeah, that's it for today. Thank you very much for your attention. Please don't forget to leave a comment if you have any questions. Please don't hesitate to ask me in the comment section. Also like and subscribe to the channel. Thank you very much for your attention, and we'll see you in the next videos. Have a good time.